Hello everyone, my name is Tom Zhang and I will be hosting today's webinar. Welcome back to another IKD webinar series. We have some exciting content to share today, along with a very special guest. But before we start the webinar, we have rules of the webinar. If you encounter any technical difficulties during the webinar, please call us at 877-316-6140 or 502-244-4031 and say webinar issues. If you get disconnected, go to www.gotowebinar.com and click join a webinar. The webinar ID for this session is 615-325-363. We do encourage questions, but during the webinar, your microphones will be muted. Please type your question in the question box and we will answer as many questions as time allows at the end of the webinar. We are recording this session live right now, and once we're done, we will upload this to our YouTube channel. Today's topics include introductions to Bel-Ray, our IKD Trusted Partners Group, a little bit on the basics of webinar, some concepts related to priming, running in compounds. We'll discuss a couple of different lubricants for open gear applications, a subtopic on the difference between a synthetic and a non-synthetic, and then an overview by the end of the webinar, and of course questions and answers and discussions. Today we will be introducing a very special guest speaker. His name is Don Howard. He is the Senior Technical Service Manager in Mining for Bellray and at this point Calumet Lubricants. He's previously an R&D manager. He's got 40 plus years at Bellray, 30 plus years direct involvement in mining lubrication related to product line management, R&D, technical services. And from here on out, I'll let Don speak, and I will interject every once in a while. Don?
Okay, thanks, Tom. First thing I'd like to do is introduce Bellray very briefly. The company was founded by Bill Kiefer in 1946. His approach to industry was to identify problem areas in specific industries and try to present lubricants that solve those problems. Initially, he entered the baking industry, of all things, considering where he eventually went to. But the first products were high-temperature oven chain lubricant and a high-temperature clay-based bearing grease. These products were used in baking bread, which at the time the high temperatures presented severe problems, which he solved. The company entered the mining industry in 1969 and actually brought to the industry the first pumpable cam compound for the dragline you see in the picture. Bellray was acquired by Calumet in December of 2013, so at that point we became a much bigger and diversified company.
Quick question. Isn't your dad one of the first chemists?
And my father was the first chemist. I've been with Bellray for 41 years. My father was with Bellray before me for 34 years. So we sort of have cornered the market on Bellray technology.
Right.
Bellray brand composition, this is the overall company. Of course, I list mining first because that's my area, but we also have product lines for general industry, food grade products, the marine, and also power sports. The Bellray mining line composition is complete. We have a complete portfolio for drag lines and shovels, also for process equipment and mobile equipment. The mobile equipment includes equipment like front-end loaders and the large haul trucks that you see on TV sometimes. The primary focus of the webinar is the lubrication of large open gears, specifically gears for kilns and ball mills or grinding mills in general. First, we're going to look at some basic lubrication principles. What are lubricants? Basically, a lubricant is anything that you can put between two surfaces to prevent them from contacting each other. These surfaces are in motion relative to each other, and there's generally a force applied to one or both against the other. And the lubricant, seen here in yellow, is a material that separates those surfaces. Conventional industrial lubricants are oils, greases, and some variations of them. What are the basic functions of a lubricant? Lubricants remove heat. Heat comes from either the mechanics of the operation or possibly some fluid friction. Well, a lubricant acts to carry that heat away and dissipate the temperature. Lubricants prevent rust and corrosion. They flush wear particles from the contact area. They remove contamination particles such as air-inducted abrasive materials. They help to seal applications, and they transfer energy, as in hydraulics. But the number one function of a lubricant is to protect machine surfaces against wear. Typical lubricant composition. Now, this is for all lubricants, fluids and greases, so you see a kind of a general mix here, but you typically will have 1 to 20% of performance additives such as antioxidants or anti-wear additives, rust and corrosion inhibitors. Then you may have up to 20% of viscosity modifiers. Viscosity modifier is a product that increases an oil's viscosity or will give you that multi-grade effect that you see in say 15W40 engine oils. Some lubricants also use solid lubricants such as molybdenum disulfide, graphite, or Teflon. You may see these as high as 20%. In some pastes, such as an anti-seize paste or a walking cam compound, you may see solid lubricants as high as 50%. The base components of the lubricant typically occupy the majority of the lubricant, and they would include things like mineral or synthetic base fluids, grease thickeners such as aluminum complex or lithium complex soaps, and you may find fillers such as carbon black or zinc oxide. Bellray has focused in recent years on the low-speed, one-direction gear, the large open gear that's typically found on kilns and mills. We've developed a complete program to service this equipment, and that includes products for priming the gear teeth, running in the gear teeth, and the operational compounds. In addition, we provide all of the services necessary to operate this equipment. First product type that we're going to look at is priming, getting it started right. Our typical priming lubricants are our solvent-free, heavy-duty open gear lubricants such as Moly Lube SF100 semi-synthetic open gear lubricant, grades medium, heavy, or extra heavy. These are very high-performance aluminum complex greases, very high load carrying capabilities, and they contain no solvent, so that it can be brushed onto a fresh gear tooth and be extremely adhesive, very difficult to squeeze off or wipe off. The products used for priming are typically applied by brush or spatula, most often by brush. Priming quantities. This is a good question because it really doesn't take very much. Lubricating films are typically very thin, measured on the order of microns, so it doesn't take a lot of product to paint onto a gear tooth to protect it fully at startup. This chart shows you how to determine the amount of product for a specific gear looking at face width and diameter. In our example, we have a diameter of 7,000 millimeters and a width of 800 millimeters. So we apply those numbers in the chart, and at the intersection we see that we need about 34 kilograms of grease to fully prime a gear of this size.
So Don, I got a question on the priming. Is it common to have priming, or is it recommended to have priming, or is it required to have priming?
On startup of any fresh surface, it should always be primed. Should always be pre-lubed. Running in, smoothing the roughness. This is another type of product that's used to almost resurface gear teeth while the machine is in operation. What is running in? As I just explained, it's in situ resurfacing of mill gear teeth using a special, and this is very important, non-abrasive compound. If you get into abrasive compounds, you're moving away from running in and getting into the area of repair compounds, which are actually lapping compounds. You can do a lot of damage to gears, and if any of that material happens to get into a bearing, you may as well take the bearing out right then and replace it. Why is running in beneficial? We're looking to smooth out the gear surface. A new pinion roughness on average is about 4.3 microns. After run-in, that can be brought down to about 0.4 microns to 2 microns. A smoother surface equals increased contact area, equals reduced contact pressure, and reduced wear and longer gear life. That's the key. That's the goal, is just to increase the service life of that gear. Graphically, what I just described is that the purpose of the lubricant, or the point of the lubricant, is to cover the asperities and maintain complete separation of the gear tooth surfaces. If you look at this curve, we have the average asperity height before run-in at about 4.3 microns. Then we have the typical asperity height after run-in, which is about 0.4, 0.5 microns to about 2 microns. Now, if you look at the competitor grease, it's got a typical film thickness for a particular set of gear parameter of 1.7 microns. You can see that it covers the asperity height for the gear after it's been run in most cases. If you look at the Moly Lube mill gear grease, which is a Bel-Ray product, grades heavy and medium, you can see that our film thickness exceeds those asperity heights for the run-in gear, even the tallest one at an average of 2 microns. When to run in? All new gears and pinions should be run in. Any turned gear or pinion, now a turned gear or pinion, very often these machines are running in one direction, which means that one side of the tooth sees all of the load. So if that gets damaged to a certain point and the integrity of the tooth or the gear itself has not been compromised, you can actually take the gear or the pinion and turn it and use the opposite side and essentially double the life of your gear. Also, if you have your gears in service showing uneven temperature across the tooth flank or tooth face, that's a sign that you need to run in as well. Now, I don't mean uneven temperature that you would see in a misalignment. A misalignment is very well defined with a concentration of wear at one end of the tooth and a much lesser amount of wear taking place on the other end of the tooth. But an uneven temperature means that you have random spots of temperature variation across the tooth. This means that you have random high points and random high loads corresponding to that temperature. Running in will help to smooth that out. Typical duration and volume for running in. We normally run for about 500 hours of our running in compound. And it's a high consumption rate as well, 8 grams per centimeter of tooth width per hour for the entire 500-hour process. And the reason we use so much product is so that we're continuously flushing any material that we may smooth out and wear off the teeth. We want that to be flushed out because it too can cause some damage to the gear teeth. Now the Bel-Ray product for running in, as I said before, is Moly Lube running in compound. It's a grease type of open gear lubricant. Even though it's a running in compound, it still has excellent load carrying capabilities and anti-wear capabilities because you're still dealing with the same load conditions as you would in normal operation. This process is done while the machine is operating under full production. It's a non-abrasive material. It's heat activated. This is important. Non-abrasive materials tend to not cause damage, is essentially what they do. If you get an abrasive material in a bearing, that bearing has right then and there failed. It can cause scoring on gear teeth, so we're looking for a non-abrasive material, and the way we do it is by chemical activity. And chemical activity is heat activated, meaning if you have asperity contact, you generate heat. That heat activates the chemical system, and that chemical system works on that high point to wear it down or to smooth it out in some other way. On the other hand, when you have those asperities all worn down or somehow reduced in size, and you're not generating the heat anymore, that active compound doesn't activate anymore. It just remains a component of the lubricant and doesn't do anything other than provide some load carrying capability. So it doesn't act as a running in material unless it absolutely has to. Running in measures of success. You're looking for consistent temperature across the tooth width. Some variation, maybe plus or minus 3 degrees C is okay, but once you get a little bit beyond that 3 degrees C, then you're starting to have some waviness or asperities that are not yet rectified. Vibration patterns at the pinion bearings will also improve as running in goes on. Specifics in the use of the running in compound. Again, the product can be used through the standard lubrication system. You don't have to manually spray or brush it on. You put it on your automatic spray system. You adjust your throughput so that you're hitting about 8 to 10 grams per centimeter per hour. Again, it runs for up to about 500 hours. And generally, consumption in grams per centimeter per hour on a large double pinion mill is going to be somewhere around 2 drums for the 500-hour period. So it's a significant volume of product.
Is there a consequence if you go past the 500 hours?
No, there's not a consequence if you go past the 500 hours. Sometimes running in takes longer than 500 hours. Sometimes it takes less time than 500 hours. But if you don't have the asperities contacting each other, you're not generating that heat that activates the component that performs that task. So if you go beyond the 500 hours and you're already run in, you're not going to see that function. Operational open gear lubricants. The first one we'll look at is the grease type. Our grease open gear lubricant is Moly Lube mill gear grease, and some of the features of this product and the benefits of those features are mechanical stability. The product resists breakdown and maintains consistency, which means it stays in place. It doesn't get squeezed off or run off because it's breaking down. The product is waterproof, so a water spray is not going to have any adverse effect on the lube film once it's established. It's got good thermal stability, so it's not going to excessively soften. If you happen to run a pinion that's a little bit hot, it's going to stay in place. Superior anti-wear and extreme pressure capabilities. This is there to protect the surfaces, even when you have high loads or conditions such as a boundary condition. When you're rupturing the lube film and actually getting metal to metal, you will actually have performance or protection during that time. Adhesion and retention. The product is tacky. We put it on the gear tooth, it stays there. It stays there for the duration of the lube interval, which is what it's formulated to do. And grades medium and heavy meet the AGMA viscosity recommendations for low-speed open gear lubrication. Looking at a typical grease type of open gear lubricant versus the Moly Lube mill gear grease, there are some disadvantages to the grease type of open gear lubricant that we've overcome in our Moly Lube mill gear grease. Number one is low base oil viscosity. Well, as I just said, we formulated the Moly Lube mill gear grease to have a base fluid viscosity that meets the minimum AGMA guidelines. The product operates in the boundary mode. Well, that's fine. This type of product is made to operate in the boundary mode, and we compound the material with a very good extreme pressure and anti-wear chemistry that prevent wear in the boundary condition. And there's always a question of the fluidity of spent lubricant. A key feature of open gear lubricants for especially mills is that as the product is used and comes off the gear teeth, you don't want it to accumulate in the cover. You want it to drain down below the gear and eventually find its way to a waste collection drum. Well, we've built that feature into Moly Lube mill gear grease. Even though the product is a grease, it's a 00 grease, it does readily flow to waste. Moly Lube mill gear grease on the competition. If you look at the viscosity of the mill gear grease grades medium and heavy, designated as M and H obviously, you can see our viscosity numbers are quite a bit higher than what our European grease OGL competitors are using. It's kind of standard for the European companies to use lower base fluid viscosities than the companies here in the United States. But if you compare these numbers, the Moly Lube mill gear grease numbers with the European competitors to the AGMA recommendations, you can see they do not comply, whereas the Moly Lube mill gear grease medium and heavy do comply. This is a very important point because it does contribute to, or it is what makes film thickness. Again, looking at a standard set of gear tooth parameters, film thickness at 60 degrees C in microns, you can compare the mill gear grease medium and heavy versus the two European competitors, and you can see we're essentially twice as thick.
So to kind of review that a little bit, what I understand is the higher viscosity gives you a higher film thickness.
Gives a better film thickness,
and the
yes.
film thickness is what gives you that protective layer between the two metal surfaces.
It's what gives you the separation.
Okay.
Specifics in the use of Moly Lube mill gear grease. Again, it's through the standard spray system. Duration. This is your continuous operational material. This is the product that once you prime and run in, you put this product in place, and this product is the lubricant that's going to remain in place for as long as that machine is running. Consumption in grams per centimeter, again looking at a large double pinion mill, you're talking about 14 to 15 drums of grease per year. So it's a significant sale, and most places don't have one of these machines. They'll typically have two of these machines and maybe even 2 or 3 smaller mills in sequence with larger mills. And you can also look at SAG mills, which are going to be very big machines. Your drums per year is probably going to go up significantly considering that. Operational open gear lubricant, high viscosity synthetics. These are the state-of-the-art products. Okay, before we talk about the Bellray high viscosity synthetic lubricant, we're just going to review what synthetic lubricants are and why they're good. Synthetic lubricants are man-made custom molecules. Synthetics are highly controllable in composition and performance. Synthetics are consistent in composition and performance. This is an important characteristic or feature of synthetics, is if you have a consistent material, it's very predictable. And if it's predictable, you can control it. People don't realize this, but lubricant additives are also synthetics. Most of them are man-made or man-processed in some way, so that's a consideration as well in your formulation of a synthetic lubricant. Primary synthetic base oils used by Bel-Ray and most other lubricant manufacturers are polyalpha olefins or PAOs. This is the most common. If you were to go to a store and buy a quart bottle of synthetic engine oil, it would probably be about 85% of this material. PAOs are excellent lubricant base fluids. PAOs are typical of automotive and industrial lubricants. PAOs are synthetic paraffinic oils. That means that these are synthetic reproductions of natural mineral oils. So whatever they're refining out of crude oil to produce mineral oil, in a laboratory or a process plant, you can make a PAO with those same properties or those same characteristics, but superior properties. On the downside, PAOs are difficult to dissolve additives in, and sometimes you end up with additive separation problems or haziness, things like that. But we can fix that in the formula end. There's also significant elastomer shrinkage with PAOs. Again, through the formula, we can deal with that as well. Esters are another common synthetic fluid. These make excellent lubricants and lubricant base fluids. Esters themselves can be lubricants or lubricant additives. They have properties that lend themselves to forming films very readily and also have some really good low friction characteristics. They have excellent additive solubility, and they, again, perform very well as anti-wear and load carrying additives. On the downside, esters have significant elastomer swelling. Well, we just said that the paraffinic, or the PAO rather, has poor additive solubility and they cause elastomers to shrink. Well, if you add a small amount of ester to your PAO, you're going to neutralize that elastomer effect and you're going to have significant improvement in your additive solubility. This is why I said when we were talking about the PAOs, we can resolve those issues on the formula side. Esters are fairly expensive materials. That's why you usually see them used in small amounts, anywhere from 1 or 2% up to about 10%, unless it's specifically an ester-based material or lubricant. Low viscosity esters are reasonably priced, but as you start to build viscosity in an ester, their cost begins to jump pretty quickly. What are the saleable features of synthetic lubricants? The synthetics are durable and they have longer service lives. They're highly filterable, again contributing to a long service life. Synthetics are typically more oxidatively stable than mineral oils, again contributing to a longer service life. And all of these references to contributing to a longer service life is very important because synthetic lubricants are typically quite a bit more expensive than mineral-based lubricants. So if your mineral-based lubricant lasts 1,000 hours and your synthetic lubricant lasts 4,000 or 5,000 or 6,000 hours, you're going well beyond the break-even point, justifying the cost of a synthetic lubricant. Synthetic lubricants also have excellent low-temperature fluidity characteristics. If you take viscosity equivalent PAOs and mineral oil, the mineral oil may have a pour point or a low temperature fluidity point of, say, 0 degrees Fahrenheit, and the PAO might be minus 30 to minus 40 degrees. So it's a significant difference, significant benefit in the low temperature characteristics of the synthetic fluids. These are the typical claims that companies that manufacture synthetic lubricants make. Bel-Ray makes them, we all make them. But some of the things that are commonly claimed that we've been able to prove are improved energy efficiency for reduced operating costs and the ability to form and maintain lubricating films better than mineral oils. We have a gear dynamometer that allows us to measure these properties and calculate viscosities at operating temperature, and we'll talk a little bit about that. A few years ago, we did research comparing ISO 150, 220, and 320 formulated gear oils, mineral oil versus synthetic oil. And we have a machine, which is a gear dynamometer. It's a gear case driven by an electric motor, and on the output shaft, we have another electric motor turning in the opposite direction. And when we put power to that motor, it wants to turn in its natural direction. And so we can measure forces and torque through that gear system. And in this research, we found a significant reduction in power loss through the gear system when synthetic lubricants are used. You can see power loss percent. The first column of numbers in green represent the reduction in power loss through the system for the 150, 220, and 320 synthetic gear oils versus mineral. Now, another feature is when we ran this test, we allowed the machine to come to a natural temperature. We didn't put heat into the system. We just allowed it to heat to whatever point it was going to go to. And the numbers were all very similar. And then we calculated viscosity at those specific temperatures, and we found that the synthetic oil in all cases was about 25 to 27% higher in viscosity at operating temperature than the mineral oils were. And this is an important thing because the higher your viscosity at operating temperature, the thicker your lubricating film is, and as we said before, the thicker your lubricating film is, the better your component separation and component protection will be. So just by looking at these numbers, you can see you can provide much better protection than a mineral oil, and you can reduce your energy consumption, your power consumption. Now we're going to look at Bel-Ray Clear Gear Lubricant, which is our high viscosity synthetic open gear lubricant. Clear Gear Lubricant, again, looking at it the same way that we looked at the previous lubricant, it's got superior specific film thickness. Well, it's very high. This is a series of very high viscosity synthetic products. It makes very thick lubricating films. So it makes a very thick film to separate components. And when you talk about specific film thickness, you're talking about looking at the combination of asperity height and film thickness. And this product provides a specific film thickness that will cover up most of the typical asperities that you will encounter or that are present on your gear teeth. It operates in the pure hydrodynamic mode. That's the full fluid film mode. It controls micro-pitting. Micro-pitting is gear tooth damage that happens in the first couple of hundred cycles of a new set of gears. Micro-pitting appears as what they call gray staining or matte finish of the gear teeth, but if you look at it with magnification, you can see thousands of very tiny microscopic pits. Now these pits cause surface roughness. Roughness causes asperities. And those asperities eventually progress into, believe it or not, progressive pitting and spalling. So right in the very first couple of turns or couple of hundred turns of a gear, you can already establish your failure mode at that point. If you develop micro pitting and don't do something about it, you may as well say that the failure initiation point was within the first 200 or 300 revolutions of the gear. The product reduces power consumption, and I'll show you how it's done that in the next slide or two. It reduces temperature. We've had cases where temperature within the first 24 hours of conversion to clear gear have been reduced by 95 degrees Fahrenheit and then reduced further over the course of the next 48 hours and stayed that way for months and months. And it's just a function of cushioning and friction modification. The product also will eliminate vibration and noise. We have one customer, our servicemen went in and they said the vibration around the mill was so bad you could feel it coming up through the soles of your shoes and into your feet. We applied clear gear to the product, and 24 hours later that vibration was gone completely. So it is very good at eliminating vibration and noise. Now, looking at some power consumption reductions on a ball mill in South Africa, we looked at this mill. It had a throughput of 88 tons per hour at 779 kilowatt hours. The product was lubricated by another high viscosity synthetic lubricant. They converted to our synthetic high viscosity lubricant and decreased the power to 749 kilowatt hours. But on top of that, the throughput increased from the 88 tons initially to 91 tons per hour. So we saw a throughput increase of 3.4% and an energy consumption reduction of 7%. So this represents significant savings to the operation of this particular piece of equipment. But the additional throughput also represents additional material to sell. Again, contributing to the bottom line without really doing anything other than converting to the clear gear lubricant.
And to hit another point, or the point you just said, this is comparing to another synthetic.
Comparing to another synthetic. In fact, that synthetic, when we entered the mill market in South Africa, that synthetic occupied probably 90% of the market.
Mm.
Now, this is a similar chart that we looked at for the gear product, comparing the viscosity of the grades of clear gear to the recommended viscosities that we see in the AGMA 9005 EO2 standard. And you can see the numbers on clear gear viscosity-wise at 40 degrees is very high. Our lightest product is 4,270 typically, and our highest, most viscous product is the extra heavy at over 45,000 centistokes at 40 degrees C. That product was specifically developed for kilns, very low speed gears. Most of our mills are using the standard and the heavy product. Now, when these products are used, we typically recommend that heat be put into the system, that a drum heater and maybe some line tracings be used, only to guarantee pumping and spraying. And it's a minimal cost in comparison to the savings that the customer realizes when using the clear gear product. Now again, looking at this graph, we have our competitor grease and the Moly Lube mill gear grease, heavy and medium, traced out against the before and after asperity height. And then we add clear gear standard. This is our mid-range viscosity product under the same conditions, and you can see its film thickness is calculated to be 4.4 microns, which before the gear is even run in and the height is about 4 micron on average. Clear Gear Standard is already covering that. So Clear Gear Standard at 4.4 microns is film thickness is doubling the asperity height of the after run-in, of the run-in surface. This is why the product is so good. It just provides such a thick film that gear tooth separation is essentially guaranteed. Technology of Clear Gear. Looking at base oils, this is as I said, a synthetic fluid, but we've really carefully selected the fluids that we've used for a very specific property which relates to viscosity at pressure. All oils, all synthetic fluids tend to increase in viscosity as pressure is increased. We just happen to very carefully select the one that we thought would suit the need in the best way for the Clear Gear product. And in my opinion, this is really why the product works. We use a high-end gear oil package. This is a commercial gear oil package that we use. It provides basic properties of anti-wear, some level of extreme pressure, rust protection, corrosion protection. But we've also added a system of proprietary friction modifiers. Now these friction modifiers help to control micropitting, and they also, along with the low drag characteristics of the base fluids of Clear Gear, they tend to reduce friction, which is how we get vibration elimination and how we get operating temperature reductions. Now the next couple of slides shows how Clear Gear will actually, when applied through the normal spray system at the normal operational product rate, will go in and completely clean gears, clean the tooth roots, clean the gear covers, clean out drainage ports. So what we have here is a picture of a mill gear using one of our competitors' asphaltic type of product. It's a typical looking asphaltic material. You got a heavy black buildup on the cover. On the teeth you have a very thin, almost varnish and resin-like film. 48 hours after Clear Gear is applied through the standard spray system, that film is starting to go away. The black varnish resiny film is starting to go away, and Clear Gear has established itself as the primary lubricant. 10 days later, the gear teeth contact zones are completely clean. If you continue to use Clear Gear in this situation, you'll never have an accumulation of any sort of resiny material on the contact areas. It will clean out the roots, and you won't get any accumulations or buildup in the root again. And it will very slowly, because it's not in a live zone, but you will very slowly clean out the entire cover to the point where you're down essentially to bare metal for the entire cover. That may take a good 90 to 180 days, but it will slowly happen. Now this is a picture that gives you an idea of, number one, how adhesive and tacky Clear Gear is, and it also gives you a picture of why the Clear Gear is so efficient, so successful. First of all, when these gears are turning, they're trying to fling the lubricant off by centrifugal force. You can see that the gear and pinion are completely wrapped in a web of Clear Gear. It completely surrounds the entire circumference of the gears. Now, that means that it's remaining in place. It's not being wasted and slung off into the cover where it's not going to do anybody any good. It also means that every time you have those gear teeth mesh, those teeth are being pushed through that web of lubricant, meaning on every mesh, every tooth is being relubricated, which helps to contribute to reduced consumption and to guarantee full film formation on every tooth. Again, looking at consumption, as we did on the running in compound and our mill gear grease, if you look at a large double pinion mill, using clear gear, you're talking probably about an 8 to 9 drum per year consumption. Now, we have some pretty significant consumption reductions in with clear gear following one of our primary competitors whose main product is an asphaltic product. Typically, we will reduce consumption by between 65 and 75%. And we do this consistently, and we reduce temperature consistently. So it's a very successful product. It works very well. It's one of our fastest growing products, I think. Now, in review, looking in the blue, we're talking about priming products. Protects a new surface at startup. We're looking at Moly Lube SF100 semi-synthetic open gear lubricant, medium, heavy, or extra heavy. Probably the deciding factor on which grade you would use, medium, heavy, or extra heavy, is the ambient temperature for the region you're going to apply the product in. You have to remember you're brushing this product on, so you need to be able to do that fairly easily. The medium grade will do that much more readily at low temperature than the extra heavy grade, but the extra heavy grade will give you a much heavier startup film. Then your running in compound in the dark gray, it smooths new or rough surfaces to maximize contact area and reduce contact pressures. Our offering is Moly Lube running in compound. And for the operational compound in the yellow, which is your standard service compound for long-term continuous use, we have two products that we would recommend. Moly Lube mill gear grease, which is our aluminum complex high-performance grease, comparable to what the European companies are offering, and clear gear lubricant, which is our series of 5 high-viscosity, fully synthetic open gear lubricants, and the clear gear lubricant is our primary recommendation for the service lubricant or operational lubricant.
Okay, well, Don, that was an excellent presentation. Right now, for all our attendees, I would like to open up for questions. If you guys have any questions, there's a little questions section that you could type in. Please feel free to type in any questions you have for Don on lubrication questions on your rotary kilns, dryers, or ball mills. If you have any other concerns, please feel free to write in any questions you like. Okay, so we got a question on how these synthetics are applied to this. Is it a oiler type of system or automated spray system?
It can be used through an automatic spray system.
Mm-hmm.
It can be used through a pressure lubrication system where you have a circulating system.
Right.
Or it can even be the lower viscosity grades can even be used in an idler immersion system.
I see. Interesting. I think you touched on this a little bit. I got another question coming in on temperatures for colder climates, say maybe Canada or upper northern Europe. What's kind of the determining factor on that?
There's a couple of things that we've looked at. One of the things is pour point, which is the low temperature point of fluidity. We also look at vent meter testing and grease mobility testing, which grease mobility testing actually measures flow through a capillary. under pressure at a given temperature, and vent meter measures it's something specific to a spray system with a metering device such as an injector. And what the vent meter does is measure the ability of the lubricant to vent back pressure that's not expelled when the lubricant is put out to the application. You're looking for pressure reduction to the point where that metering device resets itself and closes the system so that it can recharge on the next cycle. So these are the things that we look at. All that having been said, because these are very high viscosity products, and even at room temperature are maybe a little bit difficult to spray or drip, we typically recommend that customer use some drum heaters, keg heaters, line tracing. I've even heard of people putting in colder climates, and not just for the clear gear, but for other open gear lubricants on mills as well, say an infrared heater over the spray bar.
Right, okay. Very nice. Okay, I got a question here. Says, does this type of lubrication system apply to chain-driven calciners and furnaces, not necessarily pinion only?
Chain drives, chain drives, you could probably use the lower viscosity clear gear, but I think you would be better off looking at other types of chain dedicated lubricants where you're sure of getting penetration into the pin and bushing, which is the key, and adequate sprocket.
Right. Do you have any?
We have in our line, we have some products like waterproof chain lubricant. It's available either in a bulk package like a drum or a keg.
Right.
And we even have it in aerosol can, which really is not practical for this application.
Right.
But,
right.
It is available.
Okay. So really not necessarily the clear gear is good for chain driven. There's other products that work better. I think you have to look at something else to optimize that. Okay. I noticed we touched a little bit on asphaltic. What would be the major differences comparing a full synthetic to an asphaltic system?
The biggest difference is, well, there are several differences, but the biggest functional difference is that asphaltics are typically naphthenic, which means they have a particular type of viscosity temperature curve. Synthetics have a different curve, which makes their viscosity at any given point along that curve much higher than the naphthenic type of asphaltic product. So at a given operating temperature with the synthetic, you're going to have better film thickness and component separation. Asphaltics will tend to be much lower. As the temperature goes up, they tend to reduce in viscosity pretty quickly.
Okay. See another question. When was clear gear developed? What was the development cycle for it?
Actually, clear gear, we began selling clear gear about 10 years ago in South America, specifically Chile, and we had the product on several mills in some of the copper mines, some of the copper processing plants. Here in the States, it's a relatively new introduction because here in the United States, our mining guys are known as shovel and dragline guys.
Right.
And it's like they didn't even know what a mill was. And so our guy in Chile told our domestic guys, you know, if you're not selling this product, there's something wrong here. You guys got to start pushing it. It's unbelievable. And they started to work with it, and they had some great successes. And our domestic guys are really good, really on the ball, know their stuff, and they did a fantastic job. And I mean, the product here in the States, I believe, is our fastest growing mining product.
Wow. Very good. Well, I think that's just about all the questions for today. If you guys have any other questions or any additional information you would like to get, please contact your customer service rep from IKD or call the toll-free number 877-316-6140, or if you're local in Kentucky, 502-244-4031. Well, thank you everybody for attending. Thank you, Don Howard from Bellray.
Sure, you're welcome.
And let's thank Bellray, our trusted partner from IKD. And pleasure. Have a good day, everybody.